Assalamualaikum warahmatullahi wabarakatuh. My name is Fadhil from Section 7 from Team Fantastic Four, and I'm going to be presenting on the project System Analysis and Design Individual Alternative Assessment for Phase 4, which is a high fidelity mock-up or prototype in MBIP Carbon Monitoring System. So let's just start quickly. We get the overview of the project. So the project background. So the Iskandar Putri City Council is working towards a low carbon future but faces challenges in project monitoring, public awareness, and centralized carbon data. To overcome this, MBPI proposes solutions like a central project management system, awareness campaigns, a centralized data repository, and automated carbon impact tools. These measures focus on boosting efficiency, accuracy, and community involvement, advancing Iskandar Putri toward a sustainable low carbon future. So, and then here's the system overview. To address the concerns effectively, this proposed system provides an innovative community monitoring platform. Decentralized infrastructure will manage projects, educational campaigns to boost user awareness, and cloud-based carbon metadata repositories. Automated tools can calculate the emission footprints from these repositories. Stakeholders, we have four. We got Iskandar Putri City Council, the MBPI, institutions inside the Iskandar Putri, the MBPI divisions and staff, and the residents of Iskandar Putri. So for the objective, there is four. So they get centralized project monitoring, use a centralized system for real-time tracking of sustainability initiative across departments, enhancing control and transparency. And then we got educational and incentive, boost public awareness of reducing household carbon footprints through educational campaigns and incentive. Provide guides, carbon calculators, and support for effective emission reduction. And then we got centralized data hub, gather carbon emission data in a centralized repository for impact reporting and strategic insights through automated processes like ETL, offering a comprehensive view of reduction efforts. Automated carbon analysis, implement tools for automated analysis of user record, precisely measuring carbon footprint reductions and eliminating manual calculation complexities. This ensures a more accurate and efficient carbon reduction process. And then, so here is the UI flow. So I'm just gonna talk in general because I'm gonna explain this later on. We got the personal details here. You can confirm they will load in, and then after that, we got the emission details, and then the full details will show all the personal and emission. It'll validate the data, and then we got the so if there's a mistake in the personal details, it'll be read out. There'll be a mistake, and then the box will be red, and then you'll be able to input the proper number or another number, and then validating data again. And then we got the emission details. So this will let you enter the proper number or the proper input or a symbol for the emission details. And then after that, it will validate the data, and it will be completed. So, the overall physical DFV 2B for MBPI carbon monitoring system. So, in the 2B system, residents fill out the predefined web forms with competition-related information. The system automatically collects and organizes resident details and carbon emission data. Complete forms are sent to the MBPI staff for automated validation and organization. Validated data is stored in resident and competition files. MBPIP analysts receive the competition data, provide energy consumption details for carbon reduction competition, and store results. The MBIP division generates a full competition report from the carbon footprint data. Residents then receive the notifications about the carbon reduction updates and achievement. So this is the picture of the so there is like four stakeholders, and then there's six total child diagrams. So this is my individual model, which is the process tree, which is for validate participant data. There are six sub-processes named, which is gather participant details, organize participant details, store participants' personal details, gather participants' consumption data, generate participants' competition data, check accuracy of competition data. So the main input for this process are participant personal details and participant consumption data. And then after that we get the main output, which is the resident details that are stored in D3, which is the resident file, validated competition data stored in D4, which is the competition file, and completed competition data. So this is the process specification for process 3. So it's number 3. The name is validate participant data. Description is data submitted by the participant from residents will be validated by the system to ensure that all the data is accurate and prepared for further computation of carbon reduction. So you get the input data flow, the participant personal data from MBPI administrator, participant energy consumption data from MBPI administrator, output data flow, resident details to data store 3, validate competition data to the store 4, completed competition data to MBPI analyst. Type of process is online, and then the process logic we use structured English. So here is the process logic, and then we get and then we get the unresolved issues. What to do if the participant data is not verified? How does the system notify residents to resubmit their form? So uh, so here we got the utilize structured English as our we use structured English as our study of project specification. This is due to the fact that the procedure consists of repetition for regarding all individual information. Apart from that, the decision structure is also required to make sure that the data is accurate before completion of carbon reduction. So here's my self-reflection. Overall, SAD or system analysis and design had been a big journey for me. I was shocked at first when we were told to make graph tables, which was something that I wouldn't think be taught in software engineering. This case study also teaches me how to solve a case by creating DFD of as is to be and various child diagrams. My favorite part will be during phase 4, which is to create a UI high-five mockup prototype. I've been a huge fan of designing or editing in general, including photo editing, which is Photoshop, video editing, Premiere Pro, and even website designing. When we were told to make a desktop-based UI, it was my first time creating a high-five prototype using a software, and I would say that I would love to make more projects using this kind of software. It fits my preference of hobby, designing an app or website. Uh, with fully functional interactions. Onto the hi-fi prototype details, it allowed me to the SAD understanding and knowledge by giving me the access to the visualization of the SAD project. It lets me experience the actual system analysis and design by giving a basic touch of how this course will be used in the workshops. All the information that we researched or learned was converted into the final piece or look, which is for me as someone who prefers learning through pictures than writing, give me a clear imagination of how it can be implemented to the real world. And then, so we're gonna move to the prototype demo. So here is the test of the hi-fi prototype. So here is the personal details. It will just only in view mode, so you can see the name, the contact number that the user put, and the address. If you can go back, if there is something that you put by mistake, it's not part of my process, so the button is not functioning for go back, and then you can just confirm. And then this is the loading, or aka where the organized participant details and also where the store participant personal details are done, and where the resident details are saved to the resident file. And then we got the gather participants consumption data. So here is they gather it. You can see that the user put emission type actor usage, and then the input number, emission type transportation input number, and then the emission type waste production input number. You can go back to the personal details if you want to go back, edit it again, or go back again, check to see if there's something wrong, and then you can just go confirm, and then they will show you a full competition data or the full details. Here you go. It have all the details and the emission type. And then you got to, and then it will validate or check the accuracy of the competition data. It will validate the data, and then see there's a mistake. Maybe because the following phone number cannot be found. They tell you to type in another one. So I have a full interaction in here. So let's go type with let's go with this one. With let's say example 146466558. We just change. Maybe we put the wrong number, and then okay, and then after that we got oh, the wrong. There's a symbol that cannot be read, so we need to put only numbers. Okay, we'll do 25 mpg, and then we'll validate the data again, and then when it is completed, here you go, it's completed, then it'll be gone to the validated competition data will go to the D4 competition file, and then yeah, and we'll also send the completed competition data. So that's it for my project.